Good evening everyone, myself Gautam Sharma. I welcome you all in a Sapiens Education. So this is part third video of the wave optics. So I will discuss about the coherent source of light in this and apart from this the condition for the young double slit experiment. So let us consider this is the diagram. So from here diagram, let us consider this is your single source and it will create a wave like this. So what will happen when it reach to this point? So this is your slit, thin opening slit. It's like when you see in from front, so you will get two holes. So this is thin slit, or you can also say that thin opening. Thin opening is considered as a thin slit. So when it reaches, so we have a how many sources of light? So we will have a two sources of light, independent sources of light. But one thing you will observe that their source are same. Their source are same. Source are same, and if their source are same, so it means their lambda will be same, phase difference will be same, phase they will have a same frequency, right? So these are considered as a coherent source of light. Now let us define coherent source of light. A source of light which emits a continuous light wave of a same wavelength and same frequency and same phase, or having a constant phase difference, may be same phase or a constant phase difference, are called as coherent source of light. So there may be a constant phase difference or there may be a same phase. So this type of source of light is known as coherent source of light. Now the two independent source of light cannot be coherent. If you are taking two independent source of light, so it cannot be coherent. Reason: even the tiniest source of the source consists of millions of atoms, and emission of light by them take place independently. The millions of atoms of a same source cannot emit wave in a same phase. Okay, a million of atoms cannot see here. This there are millions of atom here. There are millions of atom. So every atom cannot be, or millions of atom cannot be creating a same type of disturbance. Okay, and light emitted by the individual atom and not by the bulk matter acting as a whole. So it is individual atom, it is not like bulk matter. So this part and this part will emit the light of the same phase, same frequency, right? Now coherent source of light can be obtained by the deriving two source from the source, division of wavefront as well as division of amplitude. So wavefront division we have already done. See here. So this is the wavefront division. So just we have divided this so that we can get a coherent source of light. Got it? And division of amplitude. So amplitude, when we talk about the amplitude, so these are the amplitude. So if you divide this amplitude, you will get the coherent source of light, right? Now what is superposition principle? So the resultant displacement due to the number of wave is the vector sum of the displacement produced by each of them. What is superposition principle? Let us consider this is one wave having an amplitude of y1, and there is another wave having an amplitude of y2. So the resultant wave, let us consider this, the resultant wave will be like this and it has a amplitude of y. So if you want to find a y as it will be equal to the vector sum of the y1 plus y2. So this is considered as a superposition principle. This is considered as a superposition principle. I hope you have understood this. Now what is interference of light? Meeting of same frequency and same amplitude of a wave of a same direction is known as interference. Meeting of same frequency, same amplitude wave in a same direction is called the interference. So let us consider a wave is going like this, like this, like this, like this, and another wave is going with the same phase and same amplitude. So what will happen? It is interfering. Sometimes it may happen the wave is like this and another wave which is interfering, it may be just like this. So this is called as interference. Got it? Now what are the results for the interference? See here. When crest or crest will meet, let us consider there is a wave like this, okay, and it is being created like this, and another wave. See, this is the top part and it is considered as a crest. This is the bottom part, it is considered as a trough, right? So when, see here, when we take another wave, so what you observe that another wave crest and its crest we are matching. So it means that this is constructive wave, right? And if, or we can say that it is a constructive interference. And what happens as a result, you will get the brightness. Now, if we talk about destructive, so destructive, what happens? Crest and trough will meet each other. So let us consider this is a wave, got it? And this is your crest, this is trough, this is your crest, this is your trough. Now another wave will pass like this. So what happen? Net resultant wave or net brightness will decrease. So here it's your trough, it's your crest, it's your trough, it's your crest. So whenever crest as well as trough will meet, so it will create a destructive wave. It will create a destructive wave. Got it? So this is the creation of a destructive wave. Okay. So we have understood this one superposition principle, right? Now what happen? What is the interference of a light? So let us define it. Interference of light. Light. It is the phenomena of redistribution of light energy. Phenomena of redistribution of light energy in a medium on account of superposition of light wave. Got it? At a point where the resultant intensity, that's it. Resultant intensity of light is maximum is said to be and at a point where the resultant intensity the resultant intensity of light is minimum, the interference is said to be then it is said to be it is said to be destructive interference. So I hope you have understood this. So if the wave is like this, and it has an amplitude of y1. Another wave, it has an amplitude of y2, then the resultant amplitude y is equal to y1 plus y2. Now if wave is like this, and another wave is opposite to this, so this is your y1, this is your y2, so net resultant wave will have an amplitude of y1 minus y2 or y2 minus y1, depends upon the values. Okay, so let us discuss some necessary condition for the interference. So first condition is both source of light should be coherent. Second condition, both source of light should be coherent and both source of light should be monochromatic, that is single color. Third condition, third condition, the wave, the light wave emitted should should preferably be the same amplitude, be the same amplitude, same amplitude, so that so that the dark fringe are completely dark. Two light source must be close to each other. Otherwise, path difference will be very large. Next is the two light source should be very narrow. Next is both the wave should be of same polarization. Okay, so I hope you have understood this. Now let us discuss about the Young double slit experiment. So we know that there is a two slit. It will be S1 as well as S2. Like this. So what will happen? There will be an interference, and due to this, one wave will may reach like this. So one wave may reach like this, one wave may reach like this, one wave may interference like this. So what will happen in somewhere it will be constructive, in somewhere it will be destructive. Okay, somewhere it will be constructive, somewhere it will be destructive. So this is a Young's double slit experiment has been done. Okay, now we need to derive. Let us suppose we have used two source of light, and one source is, this is your single source, one source S1, and this is source S2. But we are taking coherent source, so their amplitude will be same. So if you want to write equation for the single source, so y1, so you can write here a cos omega t, a cos omega t, where a is your amplitude. Now y1, if you talk about the y1, so this will be how much? This will be a cos omega t plus phi, cos omega t plus phi. Okay, so this is your y2. So these are the two. So both will have a same amplitude and same phase, but it may be a little bit different, but frequency will be same. Now if you want a resultant resultant intensity, so if you want resultant of the wave, so what we can use, we can use superposition principle, that is equal to y is equal to y1 plus y2. Now let us solve it. So if we want to solve it, so y will be, by the principle of principle of superposition position, y1 is equal to a cos omega t, y2 is equal to a cos omega t plus phi. So y will be equal to y1 plus y2. So this is equal to a cos omega t plus a cos omega t plus phi. Got it? Now we can break it. So we can write here a cos omega t plus a cos omega t sin phi, a cos omega t omega t cos phi, we can write minus a sin omega t sin phi, we can write. Now if we take a as a common, 1 plus cos phi, 1 plus cos phi, 1 plus cos phi, and there will be a common, that is cos omega t, minus a sin omega t minus a omega t. Okay, now let us consider phi is equal to a sine theta. So this is equation 1 and this is equation 2. Got it? Now finally y is equal to, what we can write, y is equal to cos theta cos omega t minus a sin theta sin omega t. So finally what happens? A cos omega t plus theta we can write. So this is the resultant, this. Now if we talk squaring equation, squaring and adding equation 1 and 2. So when we do square equation 1 and 2, so what we will get as a cos theta whole square plus a sin theta whole square is equal to a square 1 plus cos phi whole square plus a sin phi whole square. So we can write here a square 1 plus cos square phi plus 2 cos phi plus a square sin square phi. So from here a square plus a square cos square phi plus 2 a square cos phi plus a square sin square pi. So this will add on. So finally we will get 2a square plus 2a square cos phi is equal to a square. Now what we can do here, we can take 2 is a square as a common, so 1 plus cos phi. So this will be how much? 2a square cos into 2 cos square pi by 2. Got it? So this will be 4a square cos square pi by 2 is equal to a square. Now we know that the intensity is proportional to the amplitude square. So from here we can write intensity is equal to 4 of the amplitude square into cos square pi by 2. So this is the desired result we want. So intensity of these two light will be is equal to 4a square cos square pi by 2. Next class I will next part I will discuss about the condition for the bright fringe constructive interference, as well as condition for the dark fringe, that is known as destructive interference. So thank you for watching my video, and let be connected for the next part. Thank you.